Hi everyone, lesson 10 and 11. I'm going to do a long division with polynomials. There's a couple things that I will skip in the notes that we really will not need for our exam. So way back when you were taught division problems, if you had your 1519 divided by 7, what would you do? 7 goes into 1 0 times. 7 goes into 15 twice for 14. And then what happened? You had to subtract. And you had the 1, and this 1 came down, so you had 11. How many times does 7 go into 11? Once. 4, 7. What'd you do? Subtract the 7. So you had 4, bring down the 9, 49. And 7 goes into 49. 7 times, there's your 49. And you are left with a remainder of 0. Okay, so that was your answer. So that's what we're going to look at, but we're going to look at that using polynomials. So there's no way I'm going to have enough room. But I'll do the best I can. Okay, so what we have is we have 2x squared plus 15x plus 18 divided by x plus 6. You're going to want to write smaller so you can squeeze it all in. So what we want to happen is we want to eliminate one term at a time. So we're going to eliminate this 2x squared first. So in order to eliminate the 2x squared, you have to get the exact same value underneath it. So I have a 2x squared. Now you look at this first term of the binomial, which is x. So x times some number will give me 2x squared. What is that? That is 2x. And I put that above the x here so that I keep everything organized. So you have to take into consideration that this 2x is being multiplied by the x here to give me a 2x squared. I also have to multiply it by the 6 to give me a plus 12x. Now, just like we did previously in the number division problem, we have to subtract it. So that means we have to subtract. So when you subtract, you change both signs. So this becomes minus, this will become minus. These will cancel, leave you with a 0x squared, and this will bring a 3x. Now, just like in the division problem, the next part comes down. In this case, it's plus 18. So you want to get the exact same first term, which is 3x. So x times something will give me 3x, so it is a 3. And then you have to do 3 times 6, which is 18. Subtract both of them, minus, minus, and you're left with a remainder of 0. Okay? So what that means is you have x plus 6 times 2x plus 3 will equal this numerator of 2x squared plus 15x plus 18. And that is how you would write it. Just like that. So that would be the answer. So that means that x minus 6 is a factor when you have a remainder of 0. I am on the next page. Of course, it doesn't always work out to be 0. It doesn't always work out to be a factor. So we would have a remainder. So sometimes that will occur. And you will follow the same process. You have your x squared plus 2x minus 5 divided by x minus 3. And we have to get the exact same first term. So then x times something gives me x squared. I need an x up there. So x times x is x squared. X times negative 3 is negative 3x. Parentheses and subtraction. Minus plus. So then these x squareds cancel. I have a 5x. Bring down this minus 5. So you have 5x minus 5. We need to get rid of the x. So I need to have a 5x. So x times something gives me 5x. It is a 5. 5 times x is 5x. 5 times negative 3 is negative 15. Parentheses with the subtraction sign. Change. Change. 5x's cancel. Negative 5 plus 15 is 10. That is your remainder. So you can write it as x plus 5 plus 10 over x minus 3. Okay, the x minus 3 is over here. And that's it. That's how you would leave it. So that's what it means by the qx. This is x plus 5 is qx. The r is 10. And then x minus a is x minus 3. The next one, 2x squared minus 23x plus 17 divided by x minus 10. I need a 2x squared first. So that means I need a 2x. 2x times x is 2x squared. 2x times negative 10 is a negative 20x. Subtract, so I change both signs. I get a negative 3x plus 17. Then I need a negative 3x. So like I said, no matter what the first term is, positive or negative, it has to be the same. And so I need to multiply x times a negative 3 to get your negative 3x. Negative 3 times negative 10 is a positive 30. Parentheses, change both signs, so this becomes plus, this becomes minus. I have negative 13 in my box here. That's my remainder. So with a negative, what you have is 2x minus 3 minus 13 all over x minus 10. And that's how you would leave it. All right, we are going to go on to lesson 11. So if you have to pause it, pause the video, and I'm going to get there as well. So here I am on lesson 11, and we're going to show you another value for the binomial that you are dividing by. So what it says first is to simplify the division using polynomial long division. So x squared minus 8x plus 18 divided by x minus 2. So again, the x squared. So x times x is x squared, and then x times negative 2 is a minus 2x. Subtract that, so change both those signs. I have a negative 6x plus 18. And then I need a negative 6x here. And therefore I need to multiply by a negative 6. Negative 6 times x, negative 6 times negative 2 is a positive 12. So I need to subtract, so change both signs. And I'm left with a 6. So there's your x minus 6 with a remainder of 6. Now, what it also means is that if I take the numerator, which is x squared minus 8x plus 18, and I put in a value of 2, and where the 2 comes from is I have x minus 2 equals 0, x equals 2. So I'm going to plug that in and evaluate. So if I did 2 squared minus 8 times 2 plus 18, that equals 6, which is the exact same as the remainder. So that's what division also represents. It's the value if you substitute in the denominator that you are dividing by. So very similar in B, we have an x squared minus 2x minus 25. And we divide that by x minus 7. So I need an x squared. Therefore, we need an x up here. Okay, so x times x squared minus 7x. Remember, change the signs. Okay, so we have a minus, a plus. So we have 5x minus 25. I need a 5x. So we're going to add 5. 5 times x is the 5x, and minus 35. Change the signs. So this becomes minus, that becomes plus. And I'm left with 10, a positive 10. So if I take a 7 right here, plug it in, that's 7 squared minus 2 times 7 minus 25. You put that right in your calculator, and that is going to give you 10. Okay, the same as the remainder. And it'll work every single time, even if it's a 0. Even if it's a 0, it's not a big deal. Okay, so here is another one, 2x squared plus 11x. So for these last two, C and D, I'm going to put the answers up there for you, so you can pause the video and try them. Make sure you have them, and then you can copy what I have, or you can check your work. And then we can go over them in class tomorrow. There's something on the next page that I really need to get to. So I did a few examples, and you can try these. So there's the answer. You can pause the video. I'm also going to do letter D. I will do that out for you as well, so you can see exactly what that solution should be. So in this last example, in example D, we have a remainder of 0. So therefore, you get 0 when you put in the negative 4. So hopefully you tried it and were able to get it by using the process of eliminating one value at a time. the next part, the remainder theorem. This is a very important theorem. We'll see something with long division on the Regents exam. What it means is that when you divide the polynomial, the remainder will always be p of a, which we just did. So that will be the remainder if you substitute in. What it also means is that if the remainder is 0, then your x minus a is a factor of the polynomial in the numerator. So when you look at the ratio in exercise 2, we're not going to force you to do it one way. There's a couple ways that you can do it. If it was placed in the form qx plus r over x minus 9, which is the value of r. So if you wanted to go ahead and do the long division, you could. Or what you can do is you could take your x equals 9 and plug it in for 9 squared minus 11 times 9 plus 22. And that will equal 4, which is choice 4. Okay? If you did the long division, same thing would happen. You would get a remainder of 4, okay, which is the exact same. So when it says here, it's just saying exactly what I said. The remainder for p of x to be a factor of p of x. So if you have the remainder of 0, then it is a factor. So that's what it says. What must be true of the remainder, p of a, for x minus a to be a factor of p of x? So it has to be 0. You have to have a remainder of 0, and then that would tell you it's a factor. So when you look at these in exercise 4, determine if each of the following are factors of the listed polynomials by evaluating the polynomial. So I have x minus 3. Is that a factor? So that means that x will equal 3. So I'll have 3 squared minus 11 times 3 plus 24. All right? These are all things you put right in the calculator. That's it. So if this equals 0, and in this case it does, that means that x minus 3 is a factor. Okay, it is a factor. In B, you would try x equals negative 5. So we have 2 negative 5 squared plus 9 times negative 5 minus 2. Okay, this is exact substitution. If you wanted to do the 2x squared minus 9x, or plus 9x minus 2, such that x equals negative 5, that's the way I recommend, especially with the negatives. So when you plug that in, you get a value of 3. So that is not a factor. So x plus 5 is not a factor. The last one, x equals 1, we have x equals negative 1. So again, same thing. Put the x cubed minus 7x squared minus 11x minus 3 in your calculator such that x equals negative 1. And it'll give you an output of 0. So that is, yes, it is a factor. It is a factor of x cubed plus or minus 7x squared minus 11x minus 3. And then the last one is x minus 5, so x equals 5. So again, put that all in your calculator such that x equals 5. And what you get is negative 5. So therefore, it is not a factor. Okay. With the last one, what we have is for what value of k will x minus 4 be a factor. What I'm going to do is I'm going to put that on the sideboard tomorrow when you come to class because I'm running out of time. I only got about a minute, but I want to explain that a little longer. All right, so anything you missed, pause it, go back, look at it. If you want me to do some more long division, we'll have plenty to practice in class. Definitely going to be a long division problem at some point on the Regents exam. Okay, have a good night. We'll see you in class.